I'm Aaron. My background is I went to Stanford and got a BS and an MS in a program called Symbolic Systems. A lot of people hear that and they think, is that something from like Da Vinci Code? And that's a perfectly fine association. If you think it's going to be about like signs and symbols, that's going to be something we're talking about today. But really what we do is we study computers and people and how they relate. So it's a mixture of computer science coursework, psychology, linguistics, logic. And I put that together in studying human-computer interaction and natural language processing. And then I brought that over to Apple, where I worked on a bunch of things, most recently Siri, back when she looked like this. And I did a mixture of engineering and research and data stuff and design on the advanced development group there. And then I came to Alation. And Alation, we empower analytic collaboration in data-driven organizations. So that includes folks like Square and eBay and Safeway and other companies shown here, as well as a bunch of customers we're very excited about that we can't show in spaces like healthcare and government. And within these companies, we help people to consume data, to find and understand and use data that's relevant to them. And along the way to doing that, we help curators, who are the folks in governance and stewardship, who try to surface that for them. Today we're going to discuss a consumption-oriented approach to data stewardship and the power of just-in-time feedback in achieving that. And I think when people see a title like this, they might wonder, well, what do you mean when you say consumption? What does it mean to consume data? So I'm going to have one driving metaphor throughout this whole talk, and that metaphor is going to be driving. Okay? When you get behind the wheel of a car, you're engaging in this very high-risk, high-reward activity, and there's a lot of decisions to be made at every step of the process. Okay? So you have to start by figuring out where you want to go. You might need a map. Hopefully it's one that you can understand. And back in the day, you would take out a paper map, you'd unfold it, and you would figure out the route you want to take, and you figure out when you have to leave, and that's how you figure out, if you're going to get to where you want to go on time. Makes sense so far? And then once you're on the road, you have all these little decisions you have to make in real time, right? You have to figure out how fast should I go, which exit should I take, right? What lane should I be in at a given time, right? You have to figure all this out on your own. Should I signal? Should I brake? Should I have my high beams on, right? And in making all these decisions, trying to balance getting to the right place on time, so quickness and correctness, but also trying to be courteous to your fellow drivers and trying to comply with the law enough to not get in trouble, right? And it turns out the same thing goes for using data as an end user, an analyst, a data scientist, a business user, right? If you want to write a query, for example, you first plan your route, right? Let's say I want to find out all the orders in my organization. Well, what table do I look at to answer that question, right? I might find the name of a table and find that there's actually 48 different tables with different suffixes that all seem to have that data. So which one do I use? Which version is up to date? Right? These are the sort of questions you have to face to plan your route. And then once you're actually driving, once you're actually using data, making a report, writing a query, what have you, you have to answer questions like, well, what am I going to join this table with? How am I going to filter it? Maybe there's different ways to calculate a metric. Which definition am I going to use? Is anyone still familiar? Was working with data before? Okay, cool. Throughout this process, there's these two questions about correctness and compliance that are on your mind, right? There's the should questions, how to get the right answer. Questions like, oh, should I include Hawaii in this set to define the US? Maybe I would if I'm in finance, because it has the same federal taxes as the other states, but I wouldn't if I'm in ops, because it's an island, so I'd group it with Guam and Puerto Rico, right? So this question of how do you get the accurate answer as you write your query. And then there's questions about compliance. May I consider gender? One case we've heard from some of the folks in the credit reporting field is because of the Fair Credit Reporting Act, you're not allowed to consider demographic information like gender if you're building a machine learning classifier to do automatic credit scoring. So you have to avoid gender there. But if you're bucketing, saying, oh, what are the average credit scores by different demographic information, then you have to use things like gender. Whereas depending on the case, the compliance rules may differ, right? So we've got these questions to ensure correctness, questions to ensure compliance, and taking the time to stop and think about these things and get the right answer, right, can result in a loss of quickness. And so there's all these trade-offs at all times as you're consuming data, just like when you're driving. Okay. So we in this room, I think the majority or the plurality of people here are governors. Right? So our job is to change people's behavior to make sure they use data the right way and avoid using it the wrong way. Right? And this is in fact a role that our government takes on in trying to get us to drive better. right? And so the question I'm going to ask today is, what are the different ways the government tries to change our behavior as drivers? Can we, as people who are trying to govern data, take some of the best practices and avoid some of the pitfalls to do that? Make sense? All right. So what's one way the government has to change our driving behavior? Well, one mechanism they use is the DMV.
They're all sloths?
Well, are you saying that because he's a sloth he can't be fast? Flash, flash, 100-yard dash. Buddy, it's nice to see you.
Nice to see you, too.
Officer Judy Howe, CPD, how are you?
I am doing
Fine.
well. What
Hang in there.
can I do
Well, I was hoping you could run a
for
play.
you
Well, I was hoping you could...
today?
Okay, so the DMV has their own way of balancing compliance and quickness, right? And there's other aspects of their approach, too, that we can examine through sort of a design lens. So turns out I'm a California resident. They've been at it for 100 years here, 100 years of public service, for which we are all very grateful. And over this time, they've compiled over 100 pages of little bullet-pointed rules about things like, let's see here, how to drive around curves, right? Something that guy in the couple slides ago maybe missed, given all the motion blurs there. So we have all these different rules, and the idea is that you will memorize all of the bullet points enough that you can take a multiple choice test, right, which many of you, can recall, and then you'll internalize it enough that as you make all these 100 split-second decisions on the road, you'll do the right thing in real time, right? And there's a bunch of interesting little things going on here, like we decided to dedicate an entire page to this note about obscuring license plates. But anyway, this is the traditional approach, right? You try to write everything down, have people memorize it, and then act on it. That's the traditional approach. Now, can you imagine if this was the only way the government tried to improve our driving? Do you think there'd be more accidents and infractions, right? If we didn't have things like this, right? Things that occur just in time, that grab your attention, that are quick and actionable. Right? I think it's an interesting contrast. What's fascinating is in the data space, most people are doing things the previous slide, right? The goal is let's write all the policies down and then apply the policies to every single data asset, and then people will read it. And we've actually seen even things kind of like the driver's license test. We have a customer that before you can get credentials to the data warehouse, it's a Teradata warehouse, they have you take a test like, oh, if you're going to do an inner join across this many nodes, what are the performance characteristics going to be? And you have 3 answers, and you check C, and only once you've scored a certain point on that test do they give you your credentials, just like a driver's license. And it turns out, believe it or not, do you think nobody ever makes a mistake because they've read the manual while taking the test? No, all the time. Right? People are sending out angry emails with bright red text saying, why didn't you follow the instructions? So what we need is something just in time, like a stoplight, not just a driver's handbook. And this is what Alation tries to implement for our customers. So here are some real questions that I've excerpted from the California driver's test. Okay, boom, you're dead, right? Because even if you knew the answer, you don't have enough time to really think about this. You need to make a decision very quickly so you don't wind up in the lane of a quickly turning truck, right? So thank goodness the DMV isn't the only mechanism the government is using to improve our driving. We also have these just-in-time interventions. And these are actually pretty well designed. Not only is each of these ones I'm going to show put in the place where you are when you need it, but they also do some cool design principles. They're salient, right? There's this red little starburst here that really grabs your attention. Red's the most salient color for human beings. And they're actionable, right? It's, okay, wide right turns is well and good. Why does it matter to you? Because you shouldn't pass on the right. Okay, cool. Same thing over here. Loading zone, passengers not, whatever. Well, let's just put it right where it belongs and make it really actionable. I can stay for 4 minutes and 59 seconds, then I've got to move on. Right? Here's the best one, right? We can take the law from the handbook, print it in the place where it's relevant on the back of a bus, where you'll see it, and then we can just make literally red flashing lights in the action you should do right there in big letters. Right? This is good design. These are well-designed interventions that would work. Can we do this for our data? Right? And I think the answer is obviously it's better. I mean, if you have to choose both. If you have to choose one, I think probably choose this over this, right? There are other places where it's so obvious the intervention should be just in time, we don't even ask the question. right? Here's a quick example. This is from somewhere in Maine. It's a newspaper clipping where they're upping the speed limit from 65 to 70 in a few locations, right? But just imagine for a minute if we took all the speed limit signs down and we had something like this at City Hall. So if I go to Sacramento and I would get this map that explains for every stretch of road what the speed limit is. And we say, okay, just memorize that and then do it. Right? And take all the street signs down. You say, oh, the first one is Main Street and then Broadway, etc. And take all the traffic lights down and just say, oh, if you arrive at the intersection of Main Street and First Street, then you should stop if you're going north-south, right, between 15 seconds past and 45 seconds past each minute. And no, it's crazy, right? We wouldn't even conceive of doing that. And yet, in data, that's what we do. We write everything down, and we say people are going to memorize it and be able to follow it. Or we're going to look it up in real time. You can't look that up. You're trying to drive, right? So instead, we should be doing this. We should post the speed limit so that it's, post the rules on the data itself, not in some central place where you can then look it up, right? And better yet, instead of just looking at where the user is, the content the user is, consider what they're doing. Consider where they're going, right? Over here we show, here's your speed, right? We can observe it and feed it back to you to help you monitor your own behavior, make a better decision. And again, the really good ones will make it sound actionable. It'll flash, and it'll say, slow down, right? This is doing the right thing. All that make sense? Okay. So what does it look like for data? Here's the application in a data context. In this particular case, I'm using Alation's query tool, Compose. And what you'll see here, here's where the user has written a query that's referencing a data object that they probably shouldn't be using. Two reasons. One is correctness. You'll see here that I can use the mouse, that it's the data is stale, so the answer might not be correct, and it's not certified as HIPAA compliant, so it might not be regulatorily allowed to use this data source. So this is kind of like you're about to pull into the accessible parking space, and then you see the big blue sign. Okay, let me reverse and not use it. Over here, I've actually pushed the run button, so now the computer knows that I'm about to make a mistake. It can just intervene right there and then and say, hey, be careful. Well, that's something that will happen if you do this. So again, we see that if we can be inside the query tool, we can kind of have these street signs and these traffic lights protecting right there. What if you're not in our query tool? What if you're writing a script using a BI tool? It's sort of like asking what happens if you do a traffic infraction, there's no police there, right? You can say we're watching you. People might believe you, they might not. You can kind of scare them with Big Brother and say radar enforced. Usually this means it's a police officer with a radar gun, right? The best thing is to say, can you actually watch what people are doing, right? And observe their behavior and then intervene based on that. So if any of you guys ever seen or maybe been on the wrong side of one of these red light photo enforced signs. Right. So what happens is they have a motion sensor, and they have a camera, right? It's Internet of Things. Okay. And then you run the red light, and they snap a picture of your license plate, and if you were listening to the DMV answer man from a few slides ago and you haven't obscured your license plate, right, they'll read your plate, and they'll map it to your name and your address, and they will send, to your home mailbox a ticket. And it's going to be salient and actionable. It's going to be on a colorful piece of paper, and it's going to have a little written envelope, and it's going to say, send us, however many hundreds of dollars, right? So that's a way of kind of bringing the law to you because of the behavior you've done out in the world, even when you didn't think you were being watched, right? We can do this with data as well. Another example happens to be from Alation. We've got a data steward here, Don Thomas. He's deprecated this table, right? I'm using it somewhere else, where we can send an email saying, okay, we've been watching you, right? We've had this camera up, we've seen what you've done, and you need to change your behavior now because you're using this data asset that no longer is good to use, right? And what we do is we map from the query logs, we know what you're doing by your database credentials, kind of the equivalent of your license plate in this world, and we map from that to your name and your email, and we're able to consider intervention. Okay, so that's all fun. All of this is helping people as they're driving or as they're consuming data to not make a mistake in the first place, or once they've made a mistake, helping them correct it, right? People aren't just getting influence from the government though, right? We have cool companies like Apple and Google who make this software that actually helps people get where they want faster and get to the right place, get there correctly. And people use that a lot too. And so what you'll see here is, turn navigation. It used to be I needed a map, I'd unfold that, I'd have my route. Now, it just tells me turn right, turn left, right? It's all done, we've all used this. One cool thing that happens is, it actually helps me drive compliantly and safely as well, Because I'm not distracted looking at street signs or figuring out what lane I'm in. I can kind of stay in my lane and watch my speed limit. We can even go a step further. This is something TomTom does. TomTom is giving helpful information here. 4.1 miles, then turn right. There's a construction zone, there's traffic. And then it puts in, right, this is like one of those speed checkpoints, but it's there all the time. Right? Whenever I glance at my GPS device on the dash, I'll get this information. So it turns out, when you're helping somebody out, you have this great opportunity to influence them without antagonizing them. Right? Instead of having correctness and compliance being kind of at war with each other, what if we kind of helped people get where they want to go fast and get there correctly, and then we have this chance to modify their behavior as well. So what that means in the data context is, here's again our query tool zooming in on our feature Smart Suggest, takes into account SQL syntax and semantic search to help people write queries faster. And the idea is, this is GPS navigation for data. Right? It means turn-by-turn directions to write each bit of code in a row, based on where you are, what you've written already, and where you want to go, based on, in GPS, it's the address you enter, and it guides you. Here it's a little bit of text you type. So if I pick MAL, that could stand for male, maybe you want to do gender code equals 1, or it could be a country code, and you want to Malta, Malawi, Mali, etc. Right? Our users find this super helpful. They can write queries more correctly and more quickly. And now we have this great bully pulpit to evangelize our stewardship information. Right? I can now put a big red dot or a warning or some text next to gender code saying, hey, are you doing this for a classifier? In that case, FCRA says you really probably shouldn't be doing that. But if you're just doing aggregate analysis, then it's fine. Right? So, so anyway, the idea here is be helpful, be salient, be actionable, and be contextualized as to where somebody is and where they're going. And that's a really good way to do an intervention that's actually going to work. Right? So that's how we as stewards and governance people can change the behavior of our end users. It's really what it's all about, right? Is getting better behavior. We can also learn from the behavior people are doing. Right? So a quick example, has anyone seen Waze or used it? Cool.
Awesome.
Yeah, it's a really company acquired by Google. Their motto here is outsmarting traffic together. Right, so these people are just crowdsourcing. They'll say, oh, there's a checkpoint here, there's a traffic jam. But before Google used this active technique of people volunteering their time, they actually were looking at passive implicit signals. Right, so I'm a NorCal guy, so this picture makes me pretty happy about where I live. This is the LA area, and you'll see, it's just traffic everywhere. Well, how do they know that? A bunch of people are driving. They happen to have an Android phone in their pocket or in their cup holder. Right? And Google notices, wait a minute, 2 hours ago, all these Android phones along this corridor were moving at 60 miles an hour. And now they're moving at 5 miles an hour. And they're able to aggregate that up. Right? And in the case of car traffic, the interesting thing is that you really want to go when other people aren't going. Right? With data, often it's the reverse. It's more like this. Right? If you can see signs that everybody's doing something, that might be a best practice you want to follow as well. And so if we think about these suggestions, kind of filtered by SQL syntax and semantic search, we can further rank order them by social statistics, by how often other people are doing them in that context to guide our behavior, right? So that helps the consumers. And if you're a stewardship person, you're thinking, oh gosh, I don't want to trust the crowds, right? The wisdom of the crowds is often wrong. Well, wouldn't you want to know, once you see these tracks here, right, you can decide to put up a big no trespassing sign, right? But you want to start by observing the behavior so you know where you want to regulate and intervene and where you want to encourage things to be allowed to. So that's kind of how we can do behavior I/O. Right? We can look at what people are doing to inform our policies, and then we can change people do in the future by being really thoughtful about how we intervene and be thinking about human psychology. How do you put all this together? So we think that all this curation should be brought into and then pushed out of a central repository we call a data catalog. So the idea here is we suck in kind of computed information from the sources themselves, from databases, from BI tools, from other systems of record, and we look at the logs. We look at the query logs, who's run what queries with which credentials against which sources that we were talking about earlier, who's visited which BI reports, who's created them and updated them. And we look at the curators as well. We say, okay, let's invite crowds, Waze style, or experts in a more traditional stewardship program. This is more like, government style, and have them add their annotations to the system. And we can combine all this input, both the implicit stuff and the explicit stuff, right, from both computers and crowds and experts into this rich repository of data, how it's used, how it ought to be used. And then we can surface that for the consumers, the drivers in this scenario, through a bunch of different modalities, right? To sort of search and browse, just kind of building out the map people can choose to read as they're planning, or to push it to them directly, right, with the stoplights and the signs and the like. In this case, via query tool, via email. Those are the two examples we saw, other examples like that. Make sense? So the catalog is a central place where everything comes in and then pushed out to consumers. And it's pretty easy to set this up, right? All you have to do is basically point Alation at the systems you have. The databases themselves, whether they're relational or file systems or what have you. Point to UBI tools, your documentation, be it unstructured stuff in wikis or structured data dictionaries, inventories, and things you might have. Connect this to your identity, right? Your LDAP, your single sign-on. That's kind of like the mapping the DMV has, right? From license plate numbers to driver's licenses to names and addresses, right? And Alation can take all this information. It will sort of crawl and index these sources, the way Google crawls and indexes the web. And it will connect to each source and then connect them to each other, connect all the dots, so that your users can connect to the data they need when they need it.